In cases of more complex projects, the program grows to a size that becomes hardly manageable as a single file. It isn't easy to navigate through the code that occupies many screens. In such a situation, splitting the program into smaller units can help. In many programming languages, programming engineers can define subprograms which can be stored in separate files. Subprograms are named functions in C and C++. While they are associated with the object, they are called methods. The function contains a set of statements that usually form some logical part of the code that can be separately tested and verified, making the whole program easy to manage. Grouping many functions by creating a library stored in separate files is possible. This is how external libraries are constructed. Functions are the set of statements that are executed when the function is called. A function can accept arguments as input data and return the resulting value. Calling the function can be done by writing its name with optional arguments in parentheses. The general structure of a function is the type of the value that the function returns, the name of the function, and the list of arguments in parentheses. The following pair of curly braces contain a set of instructions, the body of the function. We already know two functions from the Arduino programming model, setup and loop. If the program is very simple, there is no need to define other functions. All statements can fit in these mandatory Arduino functions. If the program is more complex, the programmer usually tries to define additional functions containing all the statements required for its functionality and then calls them in the setup or loop functions. The setup and loop functions are declared void, means they do not return any value or accept any arguments. The brackets are empty. For example, we can write the function that calculates the sum of two arguments. Our function accepts two integer arguments and returns the integer type result. The resulting value is the argument of the return statement. Its type should match the type as declared before the function name. This function can be called from the main loop by writing its name and the values of two arguments. The arguments can be constants and variables. The returned value can be assigned to a variable or used as the argument of another function. Every software development kit has a set of ready functions that help developers to develop applications. This can significantly reduce the time and effort required to write the application code. These functions are prepared to handle inputs, outputs and files, process text, communicate using serial ports, manipulate bits and bytes, and perform mathematical calculations. Although the names of the functions usually explain their functionality, they sound different between software development kits. Refer to Arduino or other SDK documentation for details. The popularity of microcontrollers and embedded programming has caused the growth of communities of enthusiasts who create a vast amount of helpful software. This usually comes as a set of functions designed to handle specific tasks, like interfacing with graphical displays or communicating using the chosen protocol. Functions created for one purpose are grouped, forming the library. The number of libraries and their different versions is so significant that software developers use a particular library manager to ensure that libraries are up to date. Sometimes changes in the library can cause a malfunction in already written code. In such a situation, the library manager can help to keep the library stable and compatible with the rest of our project. In the world of IoT, similar to embedded systems, it is common to implement some parts of the code as functions executed asynchronously and triggered by hardware events. For example, actions should be taken after receiving new data from the sensor or communication module. It is often implemented as a function written by the programming engineer rather than the library's author. Those functions are frequently called callback functions or handlers and enable developers to inject their actions for a predefined set of activities without modifying library code. For this reason, the library contains a placeholder variable that can be assigned a function body. This is handled with the use of pointers. Using function pointers enables code to modify routines handling actions dynamically by substituting the addresses. Libraries frequently implement handler variables as a list of arrays instead of singular values, enabling the library to call more than one action.